Hi, now let's talk about NS operation queues, because we've been building up to this whole concept of a queue. First we talked about NS operations, now we're going to talk about the queues to which they are added. Creating an NS operation queue is about the simplest thing we can do. All we need to do is instantiate it and optionally give it a name or set the value of its name property. Very simple. NS operation queue, we're calling it myQueue, is equal to an allocated and initialized NS operation queue. Couldn't get any simpler than that. Then we can set myQueue.name is equal to an NS string. The name property is cool because we can get the name of a queue that is running operations at runtime for debugging purposes, and we know which queue we're dealing with. We can also use that, queue with name to add operations to the queue, but typically we simply add operations to a queue using, in this case, the myQueue object. So what exactly is a queue? Well, the biggest thing that a queue is not a thread. A queue is a collection of operations, and each operation within that queue is going to run on its own thread. And as far as possible, all the operations within a queue are going to be run concurrently. So this kind of leads to a question, or begs the question, how many concurrent threads can there be in a queue? Well, it's a really good question, and that's going to depend on the available hardware. If you have multiple cores in the processor, it's also going to depend on how many operations are already running. If the main thread, or actually the main queue, is doing a lot of stuff, then fewer threads are going to be available to the queue. But the deal is that operations will, as much as possible, be run on separate threads concurrently. They will always be run on separate threads, but they will be run concurrently as much as possible. What this means is we have no control really over what operation goes on what thread, and when those operations in a queue are going to be executed. So if we need a dependency, or if we need to wait for one operation to finish before another operation begins, we don't have a serial queue like we do in Grand Central Dispatch. So what can we do? We can set a dependency on that NS operation to be dependent upon another operation to finish. We can control the maximum number of threads that a queue will use. We can't control anything else, but we can control the maximum number of threads. So we do that through the max concurrent operation count property. So if we want to say that this queue should only at maximum run 4 concurrent threads, we can do that. We can also tell the queue to run as many as it possibly can. So in this case, myQueue.max concurrent operation count is equal to, and this is a very long constant, NS operation queue default max concurrent operation count. And this will allow that queue to run with its default concurrent maximum number of threads. So that's neat, but the bottom line is, to add an operation to a queue, this is a very simple thing to do. myQueue, add operation, whatever the operation is called, my operation. Now that my operation has probably, if it's a non-trivial operation, been declared as a subclass of NS operation. We remember that. So we just add one of those to the myQueue after we instantiate it. So that queue is going to start operations that are added to it as soon as they possibly can. So we don't call start on an NS operation added to an NS operation queue. Do not do that. It doesn't work. It's a very bad thing. So if you're adding operations to an operation queue, don't call start. The operation queue will start it for you. We can also cancel all operations in the queue, with the caveat that every operation that we cancel has to be looking at the isCanceled property, that Boolean value. It has to be looking at that and polling that value in order for that operation to be canceled. So this works the same way as NSOperation cancel. But if we use myQ cancel all operations, then all operations that poll the value of isCanceled and break out will be canceled. Any other operation will continue. We can also suspend all the operations within a queue. We can sort of pause them to be restarted later. So myQ set suspended yes will suspend all operations within the queue. myQ set suspended no will restart them, not restart them, but unpause them, so to speak, wherever they are. So we can't suspend a single operation within a queue, but we can suspend all the operations within a queue. Just as there is a main UI thread, there's also a main queue, and this is called main queue. We can get this queue and execute operations on it. So here I've declared an object called the main queue. It's an NSOperation queue, and set it equal to the return value of main queue called on the NSOperation queue receiver. So this is main queue is a class method that's called on NSOperation queue that returns the main queue. This is useful if we're in another queue and we need to access the main queue. We can also add an operation to the main queue to be performed on the main queue. We could also just perform something on the main queue. We could use Grand Central Dispatch to perform an asynchronous task on the main queue. So all of these technologies are related, and we can use them all together. But typically, if we're using NS operations and NS operation queues, we want to stay within that family of things. If we're dropping down to Grand Central Dispatch at a lower level, then we can use an NS operation here and there if it simplifies matters. But don't really mix and match these technologies. Finally, if an operation is simple enough, if it's a really simple operation, we can add it to the operation queue just as a block. And we do that by sending the add operation with block message to a queue. And we can just declare the block here, or we could have a block variable, of course, and have that someplace else, and then this would do something. So this is kind of mixing those technologies as well. This is using a Grand Central Dispatch block and adding it to an operation queue to be performed concurrently. By the way, operation queues will automatically remove their operations once they're done. So we don't have to worry about a queue full of operations that is just sitting out there waiting to be collected. It's going to be collected. Automatic reference counting handles that collection and the memory management. Now remember, in an NS operation, we need to wrap whatever we're doing inside that main method of an NS operation. We need to wrap that in an auto-release pool. That way, everything within that operation gets released. But as far as operation queues go, these are first-class objects within Objective-C and within iOS, and automatic reference counting will handle the memory management for that operation queue. So there are some advantages to using NS operation and NS operation queue, and the advantages typically outweigh the disadvantages unless we really need the lower level Grand Central Dispatch API. First of all, with operations and operation queues, there is no need to manage threading details. We don't even have to know threads are happening because the operation queue is going to manage those threads for us. Now, we can throttle down the maximum number of concurrent threads, but we don't need to know that really. If our application starts to bog down, if it starts to run a little bit slowly, you might want to think about throttling down that maximum number of threads for a queue. But if it's not, then you just want to run the default maximum. Operations in a queue are run concurrently, which is a cool thing. And we can also set up dependencies to make it look like they're being run serially, or to make each operation act like it's a serial operation. In other words, a dependency will set an operation not to be started until the operation that it is dependent on is finished. But the thing is, since these things are run concurrently, we must take care that if multiple values in a queue access the same variables, or if multiple operations within an NS operation queue access the same variables, they need to be synchronized. And they need to be synchronized from one side only. Let's say that two threads access the same value from two different NS operations. Only one should synchronize the value. Otherwise, a deadlock can occur, and we talked about that in the last discussion. What this falls under is the heading of with great power comes great responsibility. So we've talked about synchronization, we have talked about NS operation, and we've talked about NS operation queues. Now we're going to look at some demos that will kind of help us understand all of the subjects that we've talked about and wrap up this unit on concurrency and threading. Thank you very much.